Assalamualaikum and greetings. My name is Surayatul Zulainur binti Zulkifli. My registration number is 07DKA22F1009.
My name is Faizatul Aiza binti Saidan. My registration number is 07DKA22F1019.
My name is Regina Emily John and my registration number is 07DKA22F1001.
My name is Kairina Satul Kalida binti Bungsu. My number metric is 07DKA22F2048.
For our case study, our selection site to conduct observation related to building failure is 3-story and 2-story, which also known as Suk Point. Suk Point is located at Sukuningo, Sabah. This project was developed to make a building for shop and also an office. This project started in January 2022 and still under construction, which is 90% of completion. Suk Point is expected to be 100% complete within another 2 to 3 months, which is expected to finish by January 2024. Lastly, this project is fully managed and run by SETCO.
Causes of building foundation failure. A site investigation was performed to determine the failure mechanism and damage impact of the pile. To collect any relevant information, this project has already gone through 2 piling failures on different grades. The following are some cases where pile failure has occurred on the site. Case 1. One of the concrete piles broke due to the hard soil. Case 2. The pile that have been used does not insufficient spec. According to the site inspection, the failure that occurs is broken concrete pile and failure identified by know of blow which ununiform can cause the pile does not go into the ground according to the aspect that has been set.
I'll be presenting about the failures that may occur to the foundation. So building failures can often be caused by various reasons, often involving a combination of different factors, and some of the common causes include: the first one is foundation issues. Problem with the foundation such as poor soil condition, improper site preparation, or inadequate depth and strength of the foundation can cause structural instability over time. Settlement, subsidence, or shifting of the foundation can also lead to significant structural damage. The second one is poor construction quality. Substandard materials, inadequate workmanship, or disregards to building codes and standards during construction can compromise the building's integrity. Issues like improper reinforcement, faulty installation, or inadequate supervision can also contribute largely to failures. Third is design errors. Mistakes or oversight in the initial planning and design phase can lead to structural weaknesses. Errors in calculation, improper load distribution, or inadequate consideration of environmental factors can result in design failure. Lastly is material deterioration. So over time, materials used in construction can degrade due to environmental factors, corrosion, moisture, or exposure to harsh elements. This deterioration weakens the building's structural integrity and can lead to failure.
There are several methods used on the site to overcome foundation failure, such as setting out for new point for new pile. Drawing will be sent back to client, engineer, and architect to determine the location for new pile point. Drawing and location are renewed to ensure a successful foundation. Other than that, ensuring high-quality concrete pile used on site. A high-quality concrete pile must meet the specific requirements. Using concrete piles that meet the specified requirements can avoid foundation failure from occurring.
So, based on analysis in this case study, we found out that two piling failure occur on the different grades due to the poor condition of the soil. We can detect it by the number of staking machines in the soil that do not comply with the specific spec. In addition, there are factors that affect the failure of the foundations, such as poor construction qualities and materials. We can say environmental factors like corrosion, moisture, or exposures to harsh elements like steel, reinforcement, and the poor grade staking from factory of the materials suppliers also have an impact on the building, accommodating the load that also can cause the beam or column to crack for such a long time. Whether it 2 or 3 years, we can get data from that. In addition, the workmanship that not skilled or inadequate also one of the factors to the building failure, because they do not work without following the procedure and established by the standard for the construction specifications. In addition, also error in design, such as error in calculation, improper load distribution, or inadequate consideration of environmental factors also can contribute to the failure. To solve these problems, one of our recommendations for improvement in the geotechnical practice in this case study is ground improvement method. This method is procedure typically defined as using mechanical means to improve the poor ground conditions. In this method also can improve the engineering properties of the soil mass, which is treated to meet the project performance requirement. One of the techniques we use is deep soiling mixing. This technique will improve the soil strength and reduce its compressibility and make it more suitable for foundation and the structure with high bearing load requirement. The second technique is stone column installations. Stone columns are constructed by the drilling and filling borehole with the compacted crushed stone. These columns serve as reinforcing elements, greatly enhancing soil stiffness and load carrying capacity. Stone columns are particularly effective in the area with soft soil. The third technique is we call jet grouting. This method is efficient to improve a weak soil or loose soil. Through high pressure jet, cement is growing and inject into the soil while growing the drill of the roads. This process creates the cemented soil columns and improve the soil strength and providing stability. This is compacting growth. Compaction growing involves injections of low slump or low mobility growth into the soil at the high pressures. This growth displaces and displaces the surrounding soil and increase its load-bearing capacities. This technique is commonly used to stabilize loose or liquefiable soil on the site.
In conclusion, our recommendation for future work is to make sure concrete piles are ordered and bought from a factory with approved performance. To make sure the pile foundations are high quality with appropriate grade suitable for the foundation on site. Next, carry out appropriate soil testing in order to prevent finding hard soil during the installation of pile foundation.